Hello everyone, I hope you're doing well with the conic sections test. Please let me know if you have any general questions as you're going through this. So as now we have been wrapping up conic sections, we're now going to move into trigonometry. So before we begin that though, we have to go back to what you guys were first looking at in geometry and review some topics, which is, so these three items here you've seen before. This will get us ready for what most students encounter in our advanced math class or any kind of pre-calculus class. Pythagorean theorem review, special right triangles. Again, you've seen that before. And then right triangle trigonometry. That's just looking at sine, cosine, and tangent. So we want to revisit all of these because we're going to need them as we move into more advanced trig topics. So just for today is going to be a Pythagorean theorem review. Now with all three of these homeworks, I'm going to have you guys submit these homeworks, and it's going to be part of that final homework grade that I always put in at the end of the grade period. So I will have those posted as a separate assignment for you to submit. And again, it's just going to be for completion. I want to see that you guys are doing these and finishing them in a timely manner. All right, so let's take a look. The Pythagorean theorem review. The goal here is just to be able to use this theorem to solve for unknown sides of a right triangle in both simplified radical form and then approximate form. So you're going to need a calculator to approximate these values. We're always just going to round to 2 decimal places, so make sure that we're rounding correctly. Now, a lot of times the Pythagorean theorem is known as a squared plus b squared equals c squared, but depending on the figure we're given, it may not always be the letters a, b, and c. They could be switched around, so c is not always going to be the hypotenuse. So what I like to say, it's just the Pythagorean theorem is saying the square of the hypotenuse is equal to the sum of the square of both legs. So the easiest part would be to identify both legs in our right triangle and then the hypotenuse. Now, if you're looking at a figure of a right triangle, the hypotenuse is always the side that's going to be opposite or across from the right angle. If you're not given a figure and you're just looking at the side lengths, the hypotenuse is always going to be the longest side of the right triangle. So I just have some notes here on how to recognize the hypotenuse. Feel free to pause at any time so that you can copy all of this down. All right, so we're going to take a look at a few examples here just to go back over and practice our radicals, simplifying our radicals, and then writing this in approximate form. So if we're looking at this figure, we notice that the side measured 8 is a leg, and then the side down here, A, is also a leg, and then 12 is the hypotenuse. So I know you know this, but I'm just, to further help you out here, just going to label it as such. So we're going to write this as 8 squared plus A squared equals 12 squared. 8 squared is going to be 64. Then we have a squared, and then 12 squared is 144. We're going to subtract 64 from both sides, so we're going to get a squared is equal to 80. And then the simplified radical form. So right now I know back when we were looking at radicals, we technically say when we go to take the square root, we put plus or minus. But because this is side lengths, a measurement can never be negative, so we don't have to worry about the negative. So a is going to equal the square root of 80, but we want to simplify this. So if we go through our numbers, yes, 4 goes into 80, but something even larger, 16. So this is really 16 times 5. And if you needed a calculator to help you with that, that's fine. But then the square root of 16 is 4, so that comes out. So we get a 4 radical 5. This is the exact answer. It's in simplified radical form. And then this is a symbol for approximate. It just looks like a wavy equal sign. And if you were to type in radical 80 on a calculator or 4 times radical 5, we're actually getting 8.94. And again, after that, the first 4, there's another 4, so we're just leaving it at 8.94. If what was after this 4 was a 5 or larger, we would round up to an 8.95. So this is the approximate, and then we have exact. Now keep in mind, you can always check. So if you did 8 squared plus radical 80 squared, we can go back to this form of it. We should get 12 squared. So we're going to get 64 plus 80 equals 144, and we do get 144 on each side. So some are a little bit more obvious than others to check, but it's always good to go back and check that. All right, looking at second example here, side B, which is the hypotenuse. So remember, it's opposite or across from. So this is our hypotenuse. Remember, it's not always going to be C. We might not even see A, B, and C. We could see an X, Y, and Z, or an R, S, and T. So to write this out, we're just going to start with 6 squared plus 4 squared equals B squared. So we get 36 plus 16 equals B squared. This will give us 52, which is equal to B squared. So taking the square root, B is going to equal radical 52, and 4 actually goes into 52. So it's 4 times 13. So the 4 is going to come out as a 2, so we get 2 radical 13 as our exact answer. And then typing this into the calculator, square root of 52, approximating it. So B is approximately 7.21. So that's our approximate answer. And again, a quick check. Like I said, I'm not going to show for every problem, but it's very good to practice that. All right, now these are a little different. We have looked at some ACT practice problems where we were given ratios. So this is a very good example of where this can happen. Notice it says the ratio of A to B is 2 to 5. So we're going to bring in another variable. And they all have to be the same variable to compare this here. So all this means is when you compare side A to side B, it reduces or simplifies to a 2/5, but it's not necessarily going to be a 2 and a 5. So I'm just going to call side A here is going to have a length of 2x. I'm going to use like a universal variable here, which would make B 5x. And then C down here is 3 radical 7. So again, this is a good example where C is not always going to be the hypotenuse. B is our hypotenuse here. So I'm still going to take the two legs and square them. So I'm going to get, and I'm going to use parentheses here. So A squared is really the quantity 2x squared. C squared is going to be 3 radical 7 squared, so we need to revisit how to square that properly. And then B squared, or the hypotenuse squared, is going to be 5x, so that quantity squared. So this is where using the Pythagorean theorem for a more challenging type problem is going to occur. So remember, when we square 2x, it's going to be a 4x squared. When we square 3 radical 7, I'm going to do this down off to the side here. 3 radical 7 squared becomes 3 radical 7 times 3 radical 7. Even though there's parentheses, we do not use any type of distribution or FOIL method here. There's no plus or minus sign. So I could think of this as 3 times 3 radical 7 times radical 7. So 3 times 3 will give me 9. Radical 7 times itself is just 7. So I'm actually getting a 63 here. So then this becomes plus 63. And then 5x squared will give me a 25x squared. So now if I could solve for x, I could use that and substitute it back in. So I'm going to go ahead and subtract 4x squared from each side. So 63 is going to equal 21x squared. I'm going to divide both sides by 21. So I'm going to get a 3 equals x squared. And x is going to equal, now technically a plus or minus radical 3, but we can't use, the negative doesn't make sense here. So x is just going to equal a radical 3. So what this tells me now is that side A, which is 2x, is really 2 radical 3. And then side B, which is 5x, is really 5 radical 3. So here are my two answers for the length. And then I do want to check this one just because of the nature of the problem. So just to go through and check. So I'm going to take 2 radical 3, which is side A squared, plus, now I know C squared, I already did that, so I'm just going to say plus 63, I really didn't need the parentheses, is going to equal 5 radical 3 squared. So if I square 2 radical 3, that's going to be 2 times 2 times radical 3 times radical 3. So I'm going to add a 4 times 3, which is 12, plus the 63. 5 radical 3 squared is going to be 5 times 5 times radical 3 times radical 3, which is 25 times 3, which is 75. And 12 plus 63 is 75. So I know I have the correct values here for the lengths of side A and B. So again, these are the answers we were looking for. All right, go ahead and pause the video and give this one a try. It's very much like the last example, and then continue playing to see if you're correct with your work. right, so here it says the ratio of a to b is 1 to 3. So I'm just going to call a 1x or just an x. I'll write the 1 out though. And then b is going to be a 3x. Now notice a and b in this case are both the legs. So c is the hypotenuse, and it's also equal to a 5 radical 2. So as I go to write this out, I'm going to have 1x squared plus 3x. That quantity squared is going to equal the quantity of 5 radical 2 squared. So 1x squared is just x squared. Next, I'm going to get a 9x squared. And then if I square the 5, that's going to be 25 times 2. So again, we're thinking of this as 5 times 5 times radical 2 times radical 2. So I'm going to get 25 times 2, which is going to give me 50. If I combine the two x squared terms, I'm going to get a 10x squared equals 50. Divide by 10. So x squared will equal 5. And then x is going to equal radical 5. Now for these, we're not putting them in approximate forms. The exact form, simplified form, is good enough. So we want to find, again, the lengths of sides A and B. So A is equal to 1x, which is just radical 5. B is equal to 3x, which is 3 radical 5. And again, just a quick check here. So if I had x squared, that's just radical 5 squared, a squared, plus b squared is 3 radical 5 squared. Will that equal 5 radical 2 squared, which is 50? So I'm going to get a 5 here. If I square this next quantity, that's 3 times 3, which is 9. Radical 5 times radical 5 is 5, so I'm going to get a 45 here. And 5 plus 45 is 50. But again, these are our answers. This is just the check over here.